So before we get going on arithmetic sequences and things like that, we're going to do I'm going to tell you a short little story about a famous mathematician who you guys have just recently studied about. There was a teacher, I think it was a third grade teacher, and he wanted his students to add all of the numbers from 1 to 100 because he wanted to kill some time. He felt like he wanted to make these students do something so that he could keep them busy so he could do something else. So he asked his students to add the numbers from 1 to 100 and tell him what the total is. And so there was one student who took an approach that was able to get his answer really quickly. And so rather than do 1 plus 2, that's 3, and then plus 3, that's 6, plus 4, and so on and so forth, what this student did was he took all of the numbers from 1 to 100 and he lined them up 1, 2, 3. And then he went all the way to 100. And then he took the numbers backwards, so he took 100, he took 99, 98, and then 1, and he added them together. 1 plus 100 is 101. 199 plus 2 is 101. 98 plus that is 101. This is all 101, in fact. Well, how many are there? Well, there were 100 numbers on the list, so there was 100 times 101. But he took one column and 2 columns. So he did twice as much as he needed to. So he divided by 2, which gives 50 times 101, which is 50/50, which is the solution to that problem that was posed by his teacher. And he did this fairly quickly, and the teacher was like, how are you done? How did you get the right answer? What did you do? And he obviously showed him this method. Well, the person who did this was the guy Gauss. And we learned about Gauss-Jordan elimination, and he obviously did this when he was in third grade. And so I just wanted to tell you that story because, the main thing that I need you to see is that there are sequences, and if you can figure out the patterns like he did here, if you just add them repeatedly 100 times, you can get this done in seconds rather than in, however long it would take you to add them one by one. Now the formula that's given for this summation is n times n plus 1 divided by 2. It works for any number. If you want to add from here to here, although you do have to modify it a little bit if you want to use it. If it starts at 1, you can use this for sure, though. So I hope that little explanation of the story was fun to hear about. Now let's get into the actual material from the website. So we're going to look at the following. We have a little pattern developing here. Notice we have these little squares. And when n is 1, you have one little square. When n is 2, you have 4 squares. When n is 3, you have 9 squares. When n is 4, you have 16. And so when n is 5, you have 25 squares. And so for A1, that would be when n is 1, that would be 1, 4, 9. When n is n, then you have n squared, whatever n is squared. Okay, so that would be the sequence here. For the next one, we've got a pattern, 4, 6, 8, 10. So this one must be 2. And this is called an arithmetic sequence. The reason it's arithmetic is because if you add repeatedly or subtract repeatedly, that is arithmetic. So A1 here is 2, 4, 6. And so what is the formula? It is simply 2 times whatever n is, right? Because if n is 1, 2 times 1 is 2, 2 times 2 is 4, so on and so forth. And then if we have 2, 4, okay, so this one goes from 4 to some number, and then that one goes from that number to 16. What is the next number? So what they're doing here, they're doing 2 times 2 times 2, that would be 8, times 2, that would be 16, times 2, that would be 32. This is what we call a geometric sequence. So you've got 2, 4, 8, and this would be AN would be, this one's a little bit trickier. This would be 2 to the n. Why? Because 2 to the 1 is 2, 2 to the 2 is 4, 2 to the 3 is 8, and so on and so forth. Okay, so that concludes this first video. We're going to get into more parts of this next, and then we'll be doing some actual examples and things like that in the other videos to follow.